Welcome to part 3 of analytical geometry, and in this part we're going to look at angle of inclination. Just the one video, we'll look at an introduction and then 4 examples. Okay, so let's head into it and see what is angle of inclination. So let's say we've got a straight line that goes through the origin up to a certain point. And if we wanted to see what the gradient of that line is, we kind of had a bit of a sense of a triangle to go, well, there's a triangle, nice, whoop, right angle triangle. And we go, oh, well, if we wanted to work out what the gradient is, oh, well, we always think kind of rise over run. Well, this is how much we're rising by. This is how much we're running by. Okay, easy enough. Now, the angle of inclination is this angle theta of how far up in terms of degrees or radians, but what angle is the straight line making from the positive x-axis. So that angle theta. Now, if we look a little bit at our trig, I don't know how much trig or trigonometry you've got under your belt, but if we look at a tan theta, all we need to know is that tan theta is opposite over adjacent. Well, in this little triangle here, opposite is rise and adjacent is run. So in other words, what we've seen here is that if we take tan of this angle, we'll get the same as the gradient. So that's what we're going to use. We're going to say that tan theta, tan of the angle of inclination, is always equal to the gradient. And we'll see in our examples how this works when it's a negative gradient in that. Okay, so that's our concept, and our one kind of take home is that we're just going to remember that little formula there. Yeah, so determine the angle of inclination through the line passing through -4, 2, and 3, 6. Okay, so I've got a little Cartesian plan because I think for these a little sketch is so useful. So let's have a look. -4, 2 is probably about, give or take, where do we want to put it? About there. And 3, 6 would be, well, a little bit less there. And if that's 2, then sort of about there. So notice it's not a perfect sketch, but it's not perfectly to scale, but it's got vaguely the right properties. I didn't put the second point down here. That wouldn't make any sense. Okay, so if we've got a line that's going through those points, I said that the angle of inclination is the angle between the x-axis and that line. So let's extend this line to hit the x-axis, because then we can see that our angle of inclination is just that angle there. So we have a bit of a sense of what that angle is. Now notice we could move ourselves out the way and say, well, let's draw a parallel line here. Well, this angle here would also be theta because they're corresponding angles if this is parallel here. So those are the kind of ideas we may or may not need to use as well as constructing these lines here. But our golden little rule said that gradient and tan theta would give us the same value. So we have to work out what our gradient is first. So m equals rise over run. And I'm going to go from this point here, -4, 2, to this point here, 3, 6, running along by 7, rising by 4. So that's our gradient. Okay, the importance of actually putting the coordinates in, I think, is helpful. Okay, so we know that 4/7 equals tan theta. Now I'm just going to do a bit of trig. Again, I'm not sure where you are in your trigonometry, but I'm always going to look for a reference angle by going arctan, or kind of colloquially we can just say shift tan, because that's what we'll use in our calculator, of 4/7. So this reference angle is, and let's just get our calculator up. Whoop, mine's coming up there, and there we go. And on here we can go shift tan of 4/7. That gives us 29,7. I'm just going to go to one decimal place. 29,7 degrees. And the reason I said that it's a reference angle will become more clear in the next examples. But 29,7, that is going to be that angle over there. So theta is indeed 29,7. Okay, so let's go through the next examples. so it can all start falling into place. Determine the angle of inclination of the line passing through those 2 points. Again, quick sketch, and our sketch is that we go -4, 5. So that's probably about there, give or take. And 0, 2, somewhere like that. So it's the line passing through those 2 points. We may as well keep it going. And our angle of inclination is this obtuse angle over here. And that's our angle. It needs to go all the way from the positive x-axis. Okay, so let's start like we did before. We know that we'll need our gradient. Gradients rise over run. So go for it. And reminder, hit pause. Actually do it yourself as you need to go. But I'm just going to keep bumming along here to go, wait a second, I like to have these here. 0, 2 was that point there. So I'm going to go left to right. -4 to 0 is 4. 5 to 3 is, or 5 to 2 is -3. Let's make that a bit neater. You may, again, like I said, you may be doing it by going, wait, I'm going to go 5 - 2 -4 -0. That's perfectly good to do as well. And so we've got our gradient. Gradient's negative matches our diagram. Now, we know that gradient equals tan theta. Okay. Now, again, if you've got a whole lot of trigonometry under your belt, you're going, oh, I know what to do, reference angles. If you don't, just bear with me and do this method, because I think it's going to help you with trig later. So we're going to say that our reference angle is arctan or shift tan of 3/4. Notice that I'm doing it of the positive value, not of negative 3/4. So if we get our calculator out and go shift tan of 3/4, we get a value of 36,9. 36,9, I'm just going to 1 decimal place. And now we're going to interpret, what does that 36,9 mean? Well, it's clearly not this obtuse angle here. So what we've really worked out is this angle on the other side. Which means, how are we going to find out our angle of theta? Well, yeah, exactly, it's angles on a straight line. So therefore, we can go from angles on a straight line, it's just 180 minus 36,9, because they need to add up to 180. So then we can work that out and go, well, 180 minus 36,9, 143,1. 143,1 degrees. Makes a bit more sense, it's an obtuse angle. Okay, and planting seeds for trigonometry later. Okay, so that's our second. Let's head to 2 more examples. Determine the equation of the line. Okay, so we're going to have to work out the equation of the line, which is something like y equals mx plus c. Passing through -2, -4, -2, -4, somewhere down here. -2, -4. -4. Forming an angle of 35 degrees to the positive x-axis. Yeah, this means that if we draw a straight line through here, I don't actually know where this point is, but I know that this must be 35 degrees. Or if we had a parallel line here, this would be 35 degrees. Okay, so I may not have it to scale. The y-intercept may be positive. My diagram may be way out of scale here. But I've got a sense of what that line looks like. Definitely got a positive gradient. Okay, so let's start with our gradient. Our gradient we know is equal to tan theta. Okay, well, that's easy enough. Calculator. Definitely need our calculator for this. 0,7 something something. Let's go to 1 decimal place. 0,7, give or take. Okay, so y equals 0,7x. Let's make those nice commas. Plus c. And now I think we're going to almost definitely have to go for just substituting a point. I think this is easier than trying to work with our gradients like we did before. I'm just going to substitute the point -2, -4, -2, -4 into the equation to work out what c is. Okay, so let's do that. So we're going to add 1.4 to both sides. So I think minus 2.6, but let's just check it on the calculator to go minus 4 plus, we're adding 2 times, let's just do that, 2 times 0.7, and minus 13 over 5 or minus 2.6. Depends which you prefer. Minus 2.6 is our value of c. So y equals 0.7x minus 2.6. Okay, so there we go. That's our equation of our line. Because this is 35 degrees, we will be rounding off somewhere along the way. Okay, final example here. Determine the size of BAC. This one, just think about, because it's definitely some thinking involved here. BAC, this angle over here. So this is our mystery angle. Definitely looks like we're going to have to think a bit harder than just going, gradient, tan theta. But we are going to work with gradients because we can work out the gradient of any of these lines here. So I'm just putting little ticks, but let me remove them so I don't clutter up the diagram. Okay, have a pause and try. Sketch on that. Add some other construction lines. Think through how you're going to do it. And then I'm going to do it right now. And let's see. But hit that pause. Okay, so what my strategy is going to be for this is I'm going to extend this line out here so that I can work out this value alpha. I'm going to call it alpha because that's just the angle of inclination, right? I can work out this gradient AB, so I can work out alpha because tan of alpha is just the gradient of AB. So remember, tan angle of inclination equals gradient. I'm just calling this one alpha, could have called it theta. Then I'm going to extend this line out here. I think this is what I was going to do. Yeah, let's do this. I want to do that. And we say, okay, well, I can work out what this angle of inclination here is. Let me call it beta. Because I've got, or I can find the gradient of AC. So I can work out that tan, let's give myself a bit of space here, tan beta is just the gradient of AC. Now what we've done is I've constructed a nice little triangle here where there's one side, there's another side, and there's that. And I know that the exterior angle of a triangle is equal to the sum of the opposite interior angles. So in other words, to find this mystery angle here, we just need to go beta minus alpha. So our final step is getting the right pen here, is going to be, well, this angle here, let's call it theta, that theta is just going to be beta minus alpha. Okay, so there's our overall picture. Lots of ways to solve this problem. A lot of them can be done with exterior angle of a triangle. It's a nice, neat way to do it, but you can construct parallel lines here. You can do something like that and end up with vertically opposite angles. There are lots of very cool ways to solve this. I'm just going to stick with this one and not go through all the other options. Okay, so we need our gradient AB. So gradient AB is rise over run. Well, from -1 to 4, I think I'm running by 5. From 1 to 5, I think I'm going up by 4. Which means that tan alpha is 4 over 5. 4 over 5. Okay, let's jump out. I'm in gradient mode, so I'm going to go, the gradient of AC is rise over run. So from C to A, well, I'm just running by 1, rising by 3. So the gradient is just 3. So tan beta is going to be 3. Okay, then for here, I need to work out my reference angle. Maybe you're getting a sense that the reference angle will actually just be the value of alpha, but let's just do that reference angle. As I said, just planting good ways for trigonometry. So I'm going to go arctan or shift tan of 4 over 5. Calculator to the rescue. Hello, calculator. And I think we had shift tan of 4/5 equals 38,65. I don't want to round off yet. 36,65 because I only want to round off right at the end. So I'm going to store this in my calculator. On this calculator, I can go Shift, Store, and A. So this is stored in the variable A. So if I go alpha A later, there it is. Okay, so that's why I've left the ... That is the value of alpha, that many degrees. Okay, let's do the same for beta. So we know that our reference angle will actually end up being beta. And we can go Shift tan, I'm going to call it now, of 3. And go, okay, calculator out. Shift tan of 3. 71,56. I'm going to store that in B. Shift store B. So now when I want to find out what theta is, well, theta we said was just beta minus alpha. So down here we're saying theta is just beta 71,56 minus 36,65. And that's going to give us an answer of, well, on the calculator I can just go, was it B or beta minus alpha 32,9. If I go to one decimal place, 32,9 degrees, and there we are. Kind of looks vaguely right. Obviously our diagram may not have been to scale, but looks about right. Okay, so there we go, plus some calculator tricks as well for you. So that's the end of part 3. Enjoy the exercise. I'll just move out the ways there. So enjoy exercise 3, and I'll see you in part 4.